In this video, we are going to finish covering section 7.3. We had just finished looking at the little table where we stated in which quadrants were the trig functions positive and negative. Now we are going to continue these section 7.3 with some examples where we're going to use reference angles, and we're going to introduce our first trigonometric identities, or one of our first trigonometric identities, and then wrap up with the unit circle. All right, so it says rewrite the expression in terms of the given angle's reference angle, and then evaluate the result. Write the exact answer, do not round. Okay, so start off, going to draw a picture for each one of these, or that's my suggestion, is to start off with a picture, draw the unit circle. I am going to try to plot my angle here, or draw my angle, but like I said before in the last video, to me it's easier if I convert this over to degrees. So let's multiply by 180 over pi. Pi's cancel. All right, so that's going to be 13 times 180. All right, so 2340 degrees. All right, so let's see how many times we're going to have to go around the unit circle. All right, so 2340 divided by 360. We're going to go around the unit circle 6.5 times. All right, so, and this is a positive angle, so let's keep that in mind as we draw our angle. All right, there's our initial side. All right, so we're going counterclockwise since this is a positive angle, and it told us to revolve around 6.5 times. All right, so 1, 2, 3, 4, 5, 6.5. So halfway around the unit circle would be here. All right, there's our terminal side. All right, so that is 13 pi, or 2,340 degrees. All right, so terminal side, excuse me, initial side, terminal side. All right, and what is the cosine at this point in the unit circle? Cosine is the x value. Cosine here is -1. All right, so cosine of 13 pi is -1. All right, let's take a look at our next example. Cotangent of -300 degrees. This one's not too bad. All right, -300. All right, so initial side is here. We're going to be going clockwise, so this would be -90, excuse me, -180, -270. I need to go 30 degrees more to get -300. All right, so that's -300 degrees. All right, so finding the reference angle. Reference angle is going to be from the terminal side. Draw a line straight to the x-axis. We know that this would be -360. So what is the distance between -300 to -360? That must be 60 degrees. So that's going to be cotangent of -300 degrees is the same thing as cotangent of 60 degrees. All right, so let's take a look at our unit circle. Cotangent of 60 degrees, that's going to be cosine over sine. So x over y, right, so that's 1/2 over square root of 3 over 2. Keep, change, flip. So it's 1/2 times 2 over square root of 3, which is 1 over the square root of 3. If you wanted to rationalize the denominator and get that radical out of the denominator, you would multiply the top and the bottom by square root of 3. So multiply the top and the bottom by the denominator. That's going to leave you with square root of 3 over 3. All right, so there's your answer. Now, Hawks will accept this as your answer. But if you wanted to rationalize the denominator and get rid of that radical in the bottom, you could if you wanted to. All right, and our last one, sine of 31 pi over 2. All right, so again, I like to just go ahead and convert this over to degrees. Multiply by 180 over pi. Pi's cancel. Let's see. 31 over 2 times 180. 2790. Okay, let's see how many times we gotta revolve around the unit circle. 2790 divided by 360 says go 7 3/4 revolutions. All right, so draw your unit circle. Starting here, that's our initial side. We're going counterclockwise because this is a positive angle. All right, so 7 3/4, 7.75. So 1, 2, 3, 4, 5, 6, 7. 7 1/4, 1/2, 3/4. All right, so that is 31 pi over 2 or 2790 degrees. All right, so if we drew a line straight from here to the x-axis, what's the distance between here and the x-axis? That would be 90 degrees. 90 degrees. Let's see, but we know that we're down here. Sine at that position, that's the y value, so that's -1. Right, so that's -1. Okay. Now we have some cofunction identities. It says given an angle theta measured in radians, pi over 2 minus theta is the measure of its complement. So the following identities are true for any value of theta. It says cosine theta equals sine of pi over 2 minus theta. Cosecant theta is secant of pi over 2 minus theta. And cotangent theta is tangent of pi over 2 minus theta. It says rewrite tangent of 40 degrees in terms of the appropriate cofunction. All right, so here is tangent. Remember that pi over 2 is the same thing as 90 degrees. All right, so tangent of 40 degrees equals, let's see, this is going to be tangent of, we don't know what's supposed to be in there. Okay, so we know that it's pi over 2 minus theta, or 90 degrees minus theta equals 40. So we got to figure out what is theta. All right. I'm just going to erase this because I feel like that made it look more confusing. Okay. All right. So again, you're saying, okay, well, 40 degrees has to be the same thing as this. So let's figure out what theta is. So if we're trying to get theta by itself, you could subtract 90. Negative theta equals -50 degrees. Divide both sides by -1. So theta is positive 50 degrees. All right, so that means that following this formula, tangent of 40 degrees is the same thing as cotangent of 50 degrees. All right, so tangent of 40 degrees is equal to cotangent of 50 degrees. All right, so just applying the formula. Here we have another example where we can use the cofunction identities. This time it's a multiple choice. This will be like A, B, C, and D. All right, determine which of the following is equivalent to the given expression. Sine of 3 pi over 4, which one of these is it equivalent to? All right, so looking at your cofunction identities, says sine of pi over 2 minus theta is equal to cosine of theta. All right, so sine of pi over 2 minus theta. All right, so this is supposed to be written in the form sine of pi over 2 minus theta. All right, so that means 3 pi over 4, we're going to set that equal to pi over 2 minus theta. And figure out what theta is. All right, so subtract pi over 2 from both sides. Negative theta equals, let's see, got to get a common denominator here. Common denominator would be 4, so multiply the top and the bottom by 2. All right, so that's going to be 3 pi over 4 minus 2 pi over 4. All right, so negative theta equals, let's see, 3 pi minus 2 pi is just 1 pi or pi over 4. Get theta by itself, divide both sides by -1 or multiply by -1. Theta is negative pi over 4. All right, so theta is negative pi over 4. Cofunction identity says sine of pi over 2 minus theta is equal to cosine of theta. All right, so cosine of negative pi over 4. Cosine of negative pi over 4. There it is. Cosine of negative pi over 4. All right. Number 8, determine the tangent and cotangent of theta given the following. Round your answer to 3 decimal places if necessary. All right, so we need to find tangent of theta and cotangent theta. We know that tangent is sine theta over cosine theta. We know that cotangent is cosine theta over sine theta. All right, so plugging this in, plugging in what we know, tangent theta equals sine theta is 0.7071. Cosine theta is negative 0.7071. All right, so tangent theta is -1. Because those cancel and the bottom is negative, leaves you with -1. Right. Over here, cotangent theta, cosine theta over sine theta, so that's negative 0.7071 over 0.7071. So cotangent theta is also equal to -1. Number 9, given that cosine theta equals square root of 108 over 12 and cotangent theta is negative, determine theta and cotangent theta. Write the angle theta in degrees from the interval 0 degrees to 360 degrees. Write the exact answer, do not round. Okay. So we got cosine theta equals square root of 108 over 12. Right, we know that cosine, thinking about SOHCAHTOA, cosine theta is adjacent over hypotenuse. Right, we're going to keep that in mind. Right, and then let's look back at our little table that we made the other day. I'm going to grab it real quick. It says that cosine is positive square root of 108 over 12. So cosine's positive, cotangent's negative. So let's figure out what quadrant we're in. If cosine is a positive number and cotangent is negative. All right, so it must be in the 4th quadrant because cosine's positive, cotangent's negative. All right, so we're going to draw the picture. All right. So we're somewhere down here. I'm going to draw, let's say here's our angle right here. I'm going to draw a little triangle. Then we're going to use that, the fact that cosine is adjacent over hypotenuse. Right, there's our angle. We'll call that theta. All right, so cosine is adjacent over hypotenuse. So that's square root of 108. Whoa, 108. Write that with another color so you can tell what it is. 108. All right, and hypotenuse is right here. It is 12. All right. Let's figure out what cotangent theta is. We know that cotangent theta is adjacent over opposite. So we need to know that adjacent side right there. So we're going to use Pythagorean theorem to find that out. All right, so a squared plus b squared equals c squared. We've got one leg. We know, let's say this is A, we're looking for B. All right, so that's square root of 108 squared plus b squared equals 12 squared. All right, solving for B, subtract, see, square root and a square cancel. We can subtract 108 from both sides. Then we got b squared, equals 12 squared minus 108. You can go ahead and simplify that if you want to. Let's see, 12 squared minus 108 is 36. Take the square root of both sides. B equals 6. Now, we're down here in the fourth quadrant. If we're going down in this direction, B must be negative 6. Negative 6. All right, so we're going down in the negative direction. If it was up here in the first quadrant, B would have been a positive 6, but it's down here in the fourth quadrant, so that Y value must be negative. We're below the x-axis. All right, so we can figure out what cotangent of theta is now. It's adjacent over opposite, so that's going to be 108 over negative 6. Excuse me, square root of 108 over negative 6. All right, so there's cotangent. And then to figure out what theta is, let's use the inverse cosine function on our calculator. All right, so you can see I'm in degree mode. That's what they were asking me. They told me to write the answer in degrees. All right, so make sure you're in degree mode. Now I'm going to use this fact. Cosine theta equals square root of 108 over 12. All right, so here's what's going on behind the scenes over here. So I'm starting with cosine theta equals square root of 108 over 12. I'm taking the inverse cosine of both sides. All right, so over here, inverse cosine and cosine cancel. Leaves you with just theta. And then we're going to plug that right-hand side into our calculator. Inverse cosine, you can see it's right here. So second cosine. Inverse cosine of square root of 108, get out of the radical, over 12 is 30 degrees. All right, so not too bad. Drawing the picture helps. All right, so make sure you're using these two facts here along with this table to figure out what quadrant you're in. Once you know what quadrant you're in, you can draw the picture of the triangle, then use the Pythagorean theorem to find your other missing side. then that will allow you to determine cotangent theta. Then we used inverse trig functions to find the value of theta. We have one more problem. Pretty easy. Just using the unit circle, evaluate the expressions, write the exact answer, do not round. So we're going to use the unit circle here. Cotangent of 300 degrees. So at 300 degrees, cotangent is x over y, cosine over sine. All right, so that's 1/2 over negative square root of 3 over 2. 1/2 over negative square root of 3 over 2. Keep, change, flip. That gives us 1/2 times negative 2 over square root of 3. Cancel those 2's. So it's negative 1 over the square root of 3. And again, you can enter the answer just like this on Hawks. If you wanted to rationalize the denominator and get rid of that radical, you would multiply the top and the bottom by the denominator. And that would give you negative square root of 3 over 3. So either one of those would be acceptable answers. All right, and then last problem is tangent of 7 pi over 6. All right, so locate 7 pi over 6. Tangent is y over x, so that's negative 1/2 over negative square root of 3 over 2. Negative 1/2 over negative square root of 3 over 2. All right, so keep, change, flip. Negative 1/2 times negative 2 over square root of 3. Negatives cancel, 2's cancel. Gives you 1 over the square root of 3. Again, just like before, you could rationalize this if you wanted to. Either one of these answers would be acceptable. All right, please let me know if you have any questions over section 7.3. Otherwise, I will see you in my next video. Have a good day.